Hello everybody, welcome to my channel. In this tutorial, I would like to talk about how to use XGBoost using sklearn in Python. So XGBoost, as you can see here in the picture, it's a kind of way that we improve the prediction of our model by improving the weak learners using our training data. The difference between the pegging and the boosting, that XGBoosting is a kind of boosting method, is that in the backend, we are using our data to create a predictive model. So in parallel, we are creating multiple predictive models, and then we aggregate all of them together, such as by getting the average, and then we have a unique model, which is the average version of our previous models. However, in the boosting, the training is not going to be done in parallel. However, it is doing in sequence. It means that first we train our model using the data, and then we try to improve the model performance by identifying what are the weak part of the model. So that's why here we can see that we use this model to use the train data again to improve the next predictive model, and so on. So XGBoost, naturally, it is going to have a better performance with respect to other machine learning algorithms, and it is faster normally, and it is an ensemble method, as I said. So it's going to be a combination set of the weak learners, and the objective is to improve accuracy. So we have various parameters in the XGBoost. The main ones are these three parameters, which are the number of estimator, the earliest stopping, and the learning rate. Number of estimator is going to talk about how many trees we have to build, and if we set the number of estimators too low, we are going to have underfitting. So we are not going to learn the pattern in data really well. If we put a lot of number of estimators, we are going to have the overfitting, which means that our model is going to learn perfectly the trained data. However, it's not going to perform well on the test data. So in order to have a good balance, we can use early stopping parameter, which is going to automatically stop when it finds the best number of trees. So normally it's good to have a high number of estimator, and then we use early stopping. So the model is going to stop when it is going to find the best number of the trees. So it is going to use a validation set in order to evaluate the performance of our model. And when the validation error is not reducing, it's going to stop the training. So it's a good parameter actually to avoid overfitting. And as I said, the good strategy is to put high number of estimator and the earlier stopping parameter to define the best value for stopping the training. And then we have a learning rate, which is like a weight that we use to add up the prediction. So if we put the small value, it means that we have a really high time for training of our model. So there is a higher chance that we reach to the optimal value, but we need lots of time for the training. If we put high value, we are going to have faster computation, but we may not reach to the optimum value. So putting a small learning rate and put high number of estimator and using early stopping is most of the time the best strategy to use for XGBoost parameters. So let me move to the Airbnb data that we have used always for the demo part. I'm not going to go into the part of pre-processing step. The main part is to focus on the XG boosting algorithm and how we can use the parameter that I have explained before. So the libraries, we are going to use pandas and numpy, and specifically for XGBoost, we are going to use XGB regressor, since the data that we would like to predict is the price of the room of the Airbnb. Then we have the normal parameters, normal libraries, such as the train test split, cross-validation score, and the metrics for evaluation of the training. So let me load them. And then we are going to read the data. Let me check this. Still my engine is processing and loading the libraries. Well, there we go. So here it is our data. The step that I am going to take is to drop duplicates, drop the columns that I don't want, check NA columns, fill NA values. Then we can see there is no NA value. And then I'm going to define the target variable, which is the Airbnb price, and then I'm going to use the rest of the features for training. Here I'm going to use 20% for training and 20% for testing. And this is my training value, training dataset. And here are all of the variables that I'm going to use. And here it is the type of the values for each predictor. So here I'm going to get only the categorical variable, which are having the number of unique values is less than 10. So for example, I have a neighborhood variable, which is consisting out of lots of variable. So I'm not going to use it for the training as a predictor. And here I'm just selecting the rest of numerical variable. And I'm selecting just the data using the defined predictors. Here I'm going to create a categorical variable into the dummy variable. And here we are. The normal version of XGB regressor is that we can skip not passing any parameter. Just we have to define the objective loss function, which is like the squared error. And then we are fitting our model into the training, in the X training and the Y train. So there we go. I need a bit time. Okay, that's okay. So we have trained our model. Here I'm going to, here I have defined a function to calculate the mean absolute percentage error, which is going to be a metric that I'm going to use for evaluation of my model. So here I'm going to predict my testing data. So I'm using my model to predict the output of the testing data. Here I have written validation, which is okay. And then I'm going to calculate the mean absolute error, root mean square error, and mean absolute percentage error. So as we can see, we have actually a good performance for our predictive model. So in the next step, what I want to do is to assign the parameters that we have studied together. So I'm going to define the number of estimator as 1000, and then I'm going to assign the learning rate as 0.05. Then I'm going to fit my training into my model, and then I'm going to use earliest stopping round, which is the earliest stopping parameter. I'm going to set to 5, and then since my model is going to need a validation set to stop when it is reaching to optimal value, I'm putting the validation data or testing data, which is not exactly the best strategy that we can use. So maybe it's better that we have the testing data, validation data, and the training data. So we can use the testing data here in order to use it for identifying the best number of estimates. Anyway, accept it like this from me for now. So I'm going to train my model. It is giving me the error that, not the error, but it's going to give me the warning that rectilinear is now deprecated. So I think I needed to also include here my objective plus function. So there we go. It is printing me out the parameter of the XGB regressor. And then here I'm going to validate my metrics using my predictive model. As we can see, in terms of the performance, we didn't improve so much. So maybe this is going to be the model which cannot learn more from the data. So let me put this 10 to check if we can improve a bit the result. So no, I think this is the best that our model can get using this information. So as you can see, for the root mean squared error, we have improved a bit, but it's not so much. And let me also check the evaluation result. So we can get the evaluation result by calling myModel.eval result. And then here we can see lots of values. So let me plot it actually, so we can see it better. So if I want to get the root mean squared error exactly out of my data, since as you can see, here we have the key as the validation 0, and then we have the root mean square error vector. So here I'm going to assign it to a variable, then I'm going to plot it. So as we can see, our root mean square error is really reducing till to the end of the training time, and here it's a bit like going up a bit, but I think then at this point it will stop for the training. So I hope that you learn more about the XGBoost algorithm, and I hope you know how to use this parameter for your predictive model. And that's it. See you soon. Thank you.